Have you ever looked up at the sun and wondered about its immense power? It's the heart of our solar system, giving us light and life. But it also has a wild side, giant solar flares, massive eruptions of energy that can dwarf our entire planet. We've all seen the dramatic headlines. Giant solar flare erupts. Is Earth in danger? It's easy to get caught up in the alarm, imagining these cosmic explosions knocking planets out of their orbits, like celestial billiard balls. Let's talk about a recent event that sparked a lot of buzz. A massive solar flare erupted, and headlines immediately connected it to the Atlas IIIa comet, suggesting its path might be altered. It's a captivating thought, isn't it? A battle between the sun's fury and a lonely comet's journey through space. But here's the thing. We need to separate science fiction from scientific fact. So the big question is, can a solar flare, no matter how gigantic, actually change the orbit of a comet like Atlas IIIa? The answer, in short, is no. Let's break down why. To understand this, we need to talk about what solar flares really are. They aren't giant physical pushes. A solar flare is an intense burst of radiation. Think of it like a colossal cosmic-scale flashbulb going off. Alongside this light, there's something called a coronal mass ejection, or CME. This is a massive cloud of plasma and magnetic fields that gets hurled out into space. Now, this cloud does have mass, and it does travel incredibly fast. This is what we call the solar wind. So you might be thinking, aha, a wind. It must push things, right? Well, yes, but the effect is incredibly tiny, especially when you're talking about something as massive as a comet. Imagine trying to push a cruise ship by just blowing on it. That's essentially the scale we're dealing with here. A comet, even a relatively small one, is a huge chunk of ice, rock, and dust, weighing millions of tons. The solar wind, while powerful in its own right, is just a stream of particles. The pressure it exerts is minuscule compared to the immense gravitational forces that truly govern the cosmos. The orbits of comets, planets, and everything else in our solar system are dictated by one primary force: gravity. The sun's gravitational pull is what keeps Atlas IIIa in its long, elliptical path. Isaac Newton figured this out centuries ago, and his laws of motion and universal gravitation still hold true. For a solar flare to change a comet's orbit, it would need to deliver a physical push so powerful it could compete with the gravitational pull of the entire sun. The energy in a solar flare, while immense, is mostly electromagnetic, not kinetic in that way. So, while these solar events are spectacular and can have real-world effects, like disrupting our communication satellites and creating beautiful auroras, they just don't have the muscle to change a comet's predetermined path through space. Atlas IIIa will continue on its journey, unbothered by the sun's temper tantrum, its orbit firmly locked in by the unyielding laws of gravity. It's a beautiful reminder of the incredible order and scale of our universe. Thank you so much for joining me on this cosmic journey today. If you enjoyed untangling this stellar mystery, please hit that like button and subscribe for more deep dives into the wonders of space. Stay curious,